Okay, in this electric appliance, initially we have 100% of electrical energy that is being supplied to it, and it converts it to 70% of heat energy and 25% of kinetic energy and another 5% to sound energy. So we can see that this appliance has an output of mainly heat and kinetic energy. So now we look at the options. Okay, hair dryer, it blows out hot moving air. So the output energy for a hair dryer is KE as well as the heat energy. Whereas for a loudspeaker, right, it mainly amplifies the sound. So the output energy will be sound. And electric iron, the main energy output is heat energy. And electric heater is also the same as electric iron, so it's also heat energy. So we can see that the answer should be A. Okay, to calculate the power of the motor, right, we can use two formula. Okay, method 1, we can use power is equal to work done divided by time, and method 2, we can use power is equal to energy converted over time. Okay, in order to lift an object that is 2000 Newton upwards for 10 meter, the work done is equal to force times distance. Okay, that will give us the force is 2000 times 10 meter, and we will have 20,000 joules. Okay, and in this case, right, the energy that is being converted, it will be gravitational potential energy. So to calculate the gravitational potential energy, we use the formula mgh, and mg is actually equal to the weight. Okay, so this mg is equivalent to the weight of 2000 Newton, so it becomes 2000. And the height, you raise it through a distance of 10 meter here, so it times 10. We also get 20,000 joules. Okay, why is it that the work done to lift this object up 10 meters is the same as the gravitational potential energy gained by this object? It's because the work done by the motor is being converted to the gravitational potential energy of this object. Hence, the work done and the gravitational potential energy, in this case, they are referring to the same thing. Okay, so the power can just take 20,000 divided by the time, which is 20 seconds. That will give us 1000 watt. Answer B. Okay, we have a pan and we have some liquid in it that is being heated. Okay, this part will be heated and temperature will increase. So anything that is being heated, it will expand and the volume will increase. And we know that the mass, which represents the amount of substance in the body, should not increase or decrease, so it will stay constant. So looking at the density is equal to the mass over volume. So if the mass remains constant and the volume increases, the mass will be dividing by a bigger number, hence the density should decrease. Okay, so now we look at the options. In the region of X, right, the mass should remain the same, the volume must increase, and the density should decrease. So the answer should be D. Okay, we have a substance that is being heated in enclosed space until it becomes a gas. Then after that, we remove the heater and the temperature was plotted at regular interval. And this is the graph, the cooling graph that we get. So the information that we get here is that the initial state of the substance when the temperature was recorded is gas, and the temperature decreases. So we see a horizontal constant temperature part here. Okay, when the temperature is constant, that means there is a change in state. So since it is at the gas state, right, the change in state for cooling, it should be from gas to liquid. That will be condensation. Okay, after the condensation is done, the temperature of the liquid continue to decrease until there is the next constant temperature. So this part is another state change. So it should be from liquid to solid. So this part represent solidification. Okay, so now we look at the question. What does the section PQ represent? PQ represents condensation. So the answer should be B. Okay, this diagram here shows us the wavefront of the wave. So we can take this as the crest. Okay, so the distance between successive crests is actually the wavelength. So the total distance between this to this, right, is 20 cm. So 20 cm is actually a total of 5 wavelengths. So to find the wavelength, we can just take 20 divided by 5. That will give us 4 cm. And we are given the frequency as well. The frequency is 4 Hz. So the speed is equal to f lambda. That will be 4 times 4, 16 cm per second. Okay, answer C.